There is a photograph taken in 1965 that contains a secret no one recognized for 13 years. It sits in an archive at the US Naval Observatory, a photographic plate of Pluto, one of dozens taken over the decades, stamped with a single damning word in the margin: defective. The image was filed away, forgotten. The planet, if that was what it was, appeared as a small, smeared blob, slightly elongated on one side, as if something had gone wrong with the telescope or the sky that night. The astronomers who logged it moved on to better plates. They had no way of knowing they had just photographed another world. 6 billion kilometers from the sun, in a region of the solar system that was, for most of human history, pure speculation, a small frozen body traces an elliptical path through the dark. We knew Pluto existed from 1930. Clyde Tombaugh had found it blinking faintly between two photographic exposures at Lowell Observatory, but for nearly 50 years after that, it remained essentially a dot, a pale, unresolved point of light, classified as a planet by precedent more than by rigor, sitting at the edge of everything we knew. Then, on the 22nd of June, 1978, James Christie sat down with a stack of photographic plates. He wasn't looking for anything extraordinary. He was performing a routine task, refining measurements of Pluto's orbit, the kind of painstaking archival work that fills most of an astronomer's career. The plates had been taken with the 1.5-meter Chi Strand telescope in Flagstaff, Arizona. Several of them were marked, as those older plates often were, as poor quality. Pluto's image appeared not as a clean point, but as a blob with a distinct protrusion on one side. The kind of thing you'd normally attribute to atmospheric shimmer, a slight drift in the telescope's tracking, or 100 other ordinary imperfections. Christie nearly dismissed them. What stopped him was something specific, the kind of observation that only becomes significant if you know what you're looking for. Christie had spent years studying binary stars, pairs of stars so close together their light blurs into a single elongated smear in long exposure photography. He recognized the shape. More importantly, he noticed that while Pluto's image was distorted, the background stars on the very same plates were not. They were sharp, clean points of light. That asymmetry changed everything. If the atmosphere had been turbulent or the telescope had drifted, everything in the frame would be smeared. The fact that only Pluto was affected meant the distortion wasn't an error. It was real. There was something attached to Pluto, or more precisely, something orbiting very close to it that was blurring the combined image. Christie went back into the archives. He pulled plate after plate, some going back to 1965, many of them stamped with that same dismissive word, defective, or sometimes even more explicitly, Pluto image elongated. He and his colleague Robert Harrington began to track the position of the bulge across the years. It moved. Not randomly, it circled Pluto on a fixed schedule, completing one revolution every 6.4 days. And 6.4 days was a number Christie recognized immediately. It was Pluto's own rotation period. The ghost on the photographic plates was a moon, a large one, locked in perfect synchrony with the world it orbited. The new moon received the provisional designation S-1978P1. Christie was given the right to propose a name. He chose Sharon after his wife Charlene, nicknamed Char, with the suffix "on" borrowed from the nomenclature of particle physics. Only after submitting the name did he discover what it meant. In Greek mythology, Sharon was the silent ferryman who carried the souls of the dead across the river into the underworld, the realm ruled by the god Pluto. The International Astronomical Union formally adopted the name in 1986. The coincidence, if that's what it was, has never quite lost its chill. The moment Charon's orbit was confirmed, it became one of the most important data points in planetary science. Kepler's laws allow astronomers to calculate the mass of a system if they know the orbital period and separation of two objects in mutual orbit. Before Charon, Pluto's mass was essentially a guess. Estimates varied by orders of magnitude. Some astronomers suspected it was as massive as Earth. Now, for the first time, there was a method. The answer was a shock. Pluto was tiny, roughly a sixth of the mass of Earth's moon. Not a scaled-down terrestrial planet, not a distant twin of Neptune's satellites, but something genuinely new. A small icy body at the outer edge of a debris field stretching beyond Neptune, a region we would later come to call the Kuiper Belt. Pluto wasn't an outlier. It was simply the largest of an entire population of similar objects that had gone undetected for decades. But Charon itself posed an equally unsettling question. It wasn't small. With a diameter about half that of Pluto and roughly 12% of its mass, Charon was, by any reasonable metric, enormous for a moon, especially the moon of such a small world. Earth's moon is only about 1.2% of Earth's mass. The moon of Saturn, called Titan, is enormous in absolute terms, but tiny in proportion to Saturn itself. Charon was different. Charon was so massive relative to Pluto that the two bodies didn't behave like a planet and its satellite at all. In most planet-moon systems, the center of mass, the barycenter, lies inside the planet. The moon orbits Earth and Earth makes a tiny compensating wobble, but the barycenter is buried roughly 1,700 kilometers beneath Earth's surface. For Pluto and Charon, the barycenter lies in open space, approximately 960 kilometers above Pluto's surface. Both worlds orbit this empty point between them, tracing their paths around the pivot that belongs to neither. The gravitational consequences compounded this strangeness. Our moon is tidally locked to Earth. The same hemisphere always faces us, because tidal forces have slowed its rotation to match its orbital period. Earth itself, however, still rotates freely. Pluto and Charon have gone further. Over billions of years, tidal friction has locked both bodies. Charon always shows the same face to Pluto, and Pluto always shows the same face to Charon. They are tidally locked to each other. From a vantage point on the Pluto-facing side of Charon, Pluto hangs motionless in the sky, a vast pale disk that neither rises nor sets. From the other hemisphere of Charon, Pluto is invisible. It never appears. This mutual tidal lock, combined with the external barycenter, led many scientists in the early 2000s to argue that planet and moon was simply the wrong frame. The system looked more like a binary planet, two worlds of comparable size, orbiting a common center, locked in permanent face-to-face proximity. The International Astronomical Union formally considered classifying Pluto-Charon as a double planet in 2006. The proposal was ultimately set aside in the broader, more contentious decision to reclassify Pluto as a dwarf planet, but the underlying observation remained valid. The Pluto-Charon system is genuinely unusual. There is nothing else quite like it in the solar system. For years, the best explanation for how Charon came to exist was essentially a smaller version of the story we tell about Earth's moon, a giant impact hypothesis. A large Kuiper Belt object, Proto-Charon, struck a Proto-Pluto with enough force to blast debris into orbit, and that debris coalesced into the moon we see today. The model was elegant. It explained the system's angular momentum, Charon's nearly circular orbit, and the general architecture of the binary. But it left things out. Pluto and Charon are not rocky terrestrial bodies. They are, to a large extent, ice. Water ice, specifically, mixed with rock. And ice behaves very differently from rock under the conditions of a giant impact. It fractures differently. It flows differently. It doesn't produce the same kind of molten debris disk. As computational simulations grew more sophisticated, the classic giant impact model began to fray at its edges. A newer hypothesis has emerged in its place, and it is, in some ways, more elegant precisely because it's more subtle. Instead of a catastrophic, obliterating collision, this model proposes a low-velocity grazing encounter, less a shattering and more a cosmic embrace. Two bodies moving at relatively slow speed collide at an angle, and rather than one destroying the other, they become momentarily stuck. For a few hours, there existed a single misshapen, spinning object in the outer solar system, tumbling through the dark in roughly the shape of a snowman. Then, tidal forces pulled the two components apart. They separated, but not entirely. Gravity kept them bound, and the binary system we observe today is what remained after that slow, intimate separation. This kiss and capture scenario does something the classic models struggle to do. It explains why Pluto and Charon are compositionally distinct. Pluto is denser, more rock-rich, approximately 70% rock by mass. Charon is lighter, approximately 55% rock. If the two bodies had been thoroughly mixed in a violent collision, that difference would have been erased. Instead, both bodies appear to have preserved much of their original structure, consistent with a collision gentle enough to avoid wholesale homogenization. But the formation story matters for a reason beyond composition. The initial impact, and more critically, the immense tidal stress generated as the two bodies stretched and pulled at each other during their brief coupling and eventual separation, would have deposited a significant amount of heat inside both worlds. Not surface heat, which radiates away quickly, but deep internal heat, heat trapped beneath kilometers of ice, with nowhere to go. That trapped heat became the engine of everything that followed. For 37 years after its discovery, Charon was a point of light with a number attached to it. Then, on the 14th of July 2015, NASA's New Horizons spacecraft flew through the Pluto system at roughly 14 kilometers per second, and Charon became a world. The images that arrived over the following months, transmitted slowly, one compressed strip at a time across more than 5 billion kilometers of space, revealed a surface that told a long, violent story. Charon had, at some point in its distant past, torn itself apart. Running roughly along the moon's equator is a system of colossal tectonic faults, ridges, cliffs, and chasms on a scale that dwarfs anything comparable on Earth. The most prominent of these, the informally named Serenity Chasma, extends for at least 1,800 kilometers. It plunges to depths of up to 7.5 kilometers. Earth's Grand Canyon is roughly 450 kilometers long and 1.8 kilometers deep. Serenity Chasma is more than 4 times as long and nearly 5 times as deep. These are not erosional features. No river carved them. They are pull-apart faults, the signature of a crust that was stretched under enormous internal pressure until it cracked. The mechanism behind that pressure is a peculiarity of water. Most substances contract when they freeze. Water expands, and the internal heat deposited by Charon's formation, supplemented by the slow radioactive decay of elements in its rocky core, was sufficient in the early history of the moon to melt the water ice deep inside it. Beneath a solid frozen crust, a liquid ocean formed. For a time, Charon was an ocean world, warm, dark, entirely sealed from the vacuum of space above it. Then, over millions of years, that ocean began to freeze. As it did, it expanded. The pressure on the overlying crust built steadily, incrementally, until the surface simply gave way. The crust ruptured, cracked, collapsed along fault lines that still scar the moon today. The belt of chasms running along Charon's equator is the visible record of that failure, a fossilized seam where the interior finally pushed through. The ocean is gone now. Charon is geologically inert, its period of internal activity long past. Without a thick atmosphere or ongoing volcanism to erode or bury these features, the surface of Charon is essentially a frozen moment, the preserved wreckage of the death of its own ocean. But the crust didn't just crack. In places, it gave way entirely. New Horizons revealed that Charon's surface tells two very different stories depending on which hemisphere you examine. The northern terrain, informally called Oz Terra, is ancient, rugged, and heavily cratered. It is the original surface of Charon, fractured and scarred by billions of years of impact and internal stress. It sits at higher elevations, rougher and more chaotic than almost any comparable terrain in the outer solar system. The southern hemisphere is different. Here, covering an enormous area, lies Vulcan Planitia, a vast, smooth plain, far less cratered than the north, sitting at lower elevation, its surface marked by features that look like frozen flows. It is, in geological terms, young. Something resurfaced it after the craters that now mark Oz Terra had already formed. That something appears to have been cryovolcanism, volcanic activity but driven by ice rather than molten rock. As Charon's subsurface ocean froze and the crust above it cracked, the expanding ice below did more than push outward. It pressurized the liquid water that remained. That water, likely mixed with ammonia acting as antifreeze, was forced upward through the newly formed fractures and fissures and erupted onto the surface. Not a lava flow, but a flow of icy slush, frigid ammonia-laced water that spread across the southern hemisphere and then slowly froze solid, burying the older terrain beneath it. Scattered across Vulcan Planitia are several isolated mountains, including one called Kubrick Mons, that sit within distinctive circular depressions, as if each mountain is surrounded by a moat. The leading interpretation is that these are blocks of the older northern crust. Ancient fragments that broke away, were carried like icebergs on the cryovolcanic flow, and were eventually locked in place as the plain solidified around them. The moats are where the ice settled against the base of each stranded block. But the crust didn't just crack. In places, it gave way entirely. New Horizons revealed that Charon's surface tells two very different stories depending on which hemisphere you examine. The northern terrain, informally called Ozterra, is ancient, rugged, and heavily cratered. It is the original surface of Charon, fractured and scarred by billions of years of impact and internal stress. It sits at higher elevations, rougher and more chaotic than almost any comparable terrain in the outer solar system. The southern hemisphere is different. Here, covering an enormous area, lies Vulcan Planitia, a vast, smooth plain, far less cratered than the north, sitting at lower elevation, its surface marked by features that look like frozen flows. It is, in geological terms, young. Something resurfaced it after the craters that now mark Ozterra had already formed. That something appears to have been cryovolcanism, volcanic activity but driven by ice rather than molten rock. As Charon's subsurface ocean froze and the crust above it cracked, the expanding ice below did more than push outward. It pressurized the liquid water that remained. That water, likely mixed with ammonia acting as antifreeze, was forced upward through the newly formed fractures and fissures and erupted onto the surface. Not a lava flow, but a flow of icy slush, frigid ammonia-laced water that spread across the southern hemisphere and then slowly froze solid, burying the older terrain beneath it. Scattered across Vulcan Planitia are several isolated mountains, including one called Kubrick Mons, that sit within distinctive circular depressions, as if each mountain is surrounded by a moat. The leading interpretation is that these are blocks of the older northern crust. Ancient fragments that broke away, were carried like icebergs on the cryovolcanic flow, and were eventually locked in place as the plain solidified around them. The moats are where the ice settled against the base of each stranded block.
And then there is the pole. Capping Charon's north is a large, dark, reddish-brown region unlike anything else on the moon. The New Horizons team named it Mordor Macula, after the Black Land from The Lord of the Rings, and the name suits it. In the images, it looks like a bruise, a concentrated discoloration that covers much of the polar region in a reddish smear. The color comes from tholins. These are complex organic molecules, reddish tar-like compounds formed when simple carbon-containing substances, particularly methane, are irradiated by ultraviolet light and cosmic rays. Tholins are common in the outer solar system. They give Pluto some of its coloring, and they appear on the surfaces of various Kuiper Belt objects. But their concentration at Charon's pole is unusual. Understanding it requires understanding where the methane came from. There are two competing hypotheses, and both are, in their own way, remarkable. The leading explanation looks outward, to Pluto itself. Pluto has a thin but measurable atmosphere, composed primarily of nitrogen and methane, gases that slowly escape into space, leaking away over geological time. Charon, orbiting close enough to intercept some of that escaping gas, acts as a cold trap. During Charon's long polar winter, which lasts over a century given the extreme axial tilt of the Pluto system,
temperatures at the pole drop below -240 degrees Celsius. At those temperatures, methane captured from Pluto's escaping atmosphere freezes directly onto the surface. When the pole finally rotates back into sunlight, that accumulated methane ice is bombarded with ultraviolet radiation and slowly cooked into tholins. Over billions of years, the deposit builds. In this model, Morf Macula is not Charon's own creation. It is Pluto's signature, written across its companion across thousands of kilometers of space. The competing hypothesis looks inward instead. The massive cryovolcanic eruptions that resurfaced Vulcan Planitia would have also released enormous quantities of dissolved gas from the subsurface ocean, including methane. This gas would have constituted a temporary primitive atmosphere on early Charon, one that subsequently migrated toward the coldest regions of the moon and froze out at the poles. The tholins, in this scenario, are a record of Charon's own geological past, a byproduct of the same events that cracked its crust and flooded its southern plains. Both hypotheses remain viable. The evidence is not yet sufficient to rule either out, but what both agree on is the deeper point. Morf Macula exists because of the relationship between these two worlds. Whether the methane came from Pluto's slowly dying atmosphere or from Charon's own frozen interior, the polar cap is a product of interconnection, of two bodies that cannot be understood in isolation from each other. The story of Charon begins with a smudge on a photographic plate marked defective, and it ends, if it ends anywhere, with a world of continent-spanning chasms, ancient icy plains, stranded mountain islands, and the mysterious polar stain that may carry the chemical legacy of its neighbor's atmosphere. In between, it transformed our understanding of the solar system. It was Charon's orbit that gave us the first true measurement of Pluto's mass, revealing it not as a small terrestrial planet, but as a large member of a new class of objects entirely. It was Charon's existence and the strange dynamics of their mutual orbit that forced planetary scientists to confront the inadequacy of the categories they had been using for decades. It was the Pluto-Charon system that became, in 2006, the central exhibit in a scientific reclassification that is still argued over today. And it is Charon's fractured surface, the chasms, the resurfaced plains, the stranded mountains, that tells a geological story directly relevant to Pluto itself. Both worlds were shaped by the same formation event, warmed by the same internal heat, and evolved under the same distant sun. What we can read on Charon's accessible, well-preserved surface informs our understanding of the processes still potentially active inside Pluto, where New Horizons found evidence of ongoing geological activity that has not yet been fully explained. In mythology, Charon was the indispensable figure of Pluto's realm, the ferryman who made the underworld function. Without him, the dead had nowhere to go. The science has turned out to be not entirely different. Charon is not simply a companion, it is the interpretive key to Pluto, the body whose existence gave us Pluto's mass, whose dynamics gave us a new framework for planetary classification, whose surface gave us a record of processes that both worlds share. They are locked together, face to face, in a gravitational embrace that has persisted for billions of years and will persist for billions more. And we found this because an astronomer in 1978 looked at a photograph that everyone else had dismissed and noticed that the background stars were sharp. Our greatest discoveries have a habit of hiding in our mistakes. This one hid there for 13 years.